All right, so what we're going to talk about here is independence as well as our multiplication rule. The multiplication rule comes through when we're looking for the probability of two events. The idea being one event occurring and then the other. So it's kind of like a sequence of events. So two events are called independent if knowing that one occurs does not change the probability that the other occurs. So it's always a sequence of one event happens and then the other follows. So we want to think about this having one thing occur and then the next thing happening. So if our events are independent, this probability of one event A occurring and then event B occurring, you just multiply the two probabilities together. So let's see this with our jelly beans. So I have our jelly beans here. And if we draw jelly beans, and some wording that we need to put in there is with replacement. What this means to have with replacement is that if I have my jelly beans, I'm going to draw one jelly bean out, and then after I record what color it is, I put it back in the bag. Being then when I choose my second jelly bean, the bag is the same. All of the jelly beans, I still have my 1 blue, 2 purple, 3 green, 4 red. So if we're working with replacement, it's a nice way to make sure things don't change. And what this does is it guarantees independence. It makes the events independent because the probabilities aren't changing if we just replace it. So we have independence because the probabilities aren't going to change if we replace them. So what's the probability of choosing a green jelly bean? And then a red jelly bean. So we have independence since we're replacing, so what we can do is just take the probability of green times the probability of red. So our probability of drawing a green jelly bean was 0.3 times probability of red was at 0.4. So when we multiply those, we'll get out a 0.12, which means there is a 12% chance of choosing a green and then a red jelly bean when we replace the jelly beans. So, when we have independence, this is what we can do. Another example of independent events is like if I was rolling a die and I wanted to talk about what's the probability of rolling a 2 and then a 3. There wouldn't be any wording about with replacement there because just a single die. However, each time you roll a die, all of them still have a 1/6 chance. It's not changing. As you see one result, it's not changing how the die functions. So those would be independent events. To start looking at what a non-independent event would look like, if we had worked without replacement. What this would mean is I would choose that first jelly bean, and then whatever color it was, say I chose a purple jelly bean, we would take it out of the group. And if we don't replace it, now how things have distributed changes. Now we only have 9 jelly beans, there's only 1 purple instead of 2, so the probabilities, all of them have changed. All the calculations here would change because our denominator would become 9, and then the numerator for purple would also change. It would be a 1 out of 9. So this is where it becomes not independent. So let's think about how this multiplication would happen then. So with looking at this probability of green and red, we take our probability of green. I mean, that's still, if this is our first choice, it's like choosing this green jelly bean as our first event. Nothing's changing there. That's still just the 0.3. because we have our 10 jelly beans in the bag and there's 3 green. But then when we go to our second event, so the second event of choosing the red jelly bean, now things have changed. It is the probability of a red jelly bean, but given that we took out a green jelly bean. So what that would mean is when we multiply, and I'm thinking about this number here for this probability, it's that we have our bag of jelly beans, we take out a green jelly bean. So now my probability of red, I have 4 red jelly beans out of and 9 left over. So our fraction changes, and we have to think about how it changes based on this first event occurring. So this is where we have the sequence of events, and we need to think about how the sequence occurs in order, and then we'll get out this decimal here. So there is a 13.33% chance of choosing a green and then a red jelly bean when we do not replace the jelly beans. So this calculation here, how things have changed based on having, it's like we have prior information. We have this information that this has already occurred, and some key wording is that what I wrote in here, probability of red, given that this has already occurred, this is called a conditional probability. And we're going to have specific notation and practice calculations with those on the next video.